In the previous video, we learned about what is tension load and what is tensile stress. In this video, we will understand one important type of stress called shear stress, which occurs due to shear load. Let us dive into the topic to understand the shear stress. First, we will understand what shear load is. Consider a lap joint as shown in the image, and which has two applied forces at the both ends. So now what will the body do? It tries to cut half the rivet from its joint through its shear forces. As you see in the second image where the cross-section of rivet is shown with the resisting forces against the applied load P. Hence the force acting tangentially to the resisting cross-section, for which body tends to shear off across the section that applied load is called shear load. So the shear load will act parallel and tangential to the cross-section of the body. The load may be equal or unequal at both ends. Do you know how the shear load reacts to the body? Consider an object with shear force in the top surface as shown in the figure. And the object is subjected to fixed support at the bottom side. Hence, it will not move in the bottom direction. Now, consider the initial load condition as 0 Newton force and final applied load to be 1,000 Newton force. Let's see how this force tries to deform the object when it has fixed support at the bottom. Did everyone saw the impact? Due to the application of the shear load, the material tends to shear in the direction of the applied load. This increase in length of the material in the direction of applied load is called deformation, and this deformation will have the change in the angle from its initial position, which you can see in the image. This reference shows the impact of the applied load, where you can see the original structure in the dotted image and the deformed object in the yellow highlighted. And the deformed section is in parallelogram shape, which is due to the applied shear load. Let us consider the free body diagram of an object which has shear force at the top surface and fixed at the bottom surface. How does this shear load react to the object? To resist the elongation, the material develops an internal resisting force within its cross-section. But how will this happen? Let us take the cross-sectional area, X. First, consider the first half top side sectional area, where the resisting force is acting on the body opposite to the applied load to resist the material from being away from its stability. Similarly, in the bottom section side also, the resisting forces will act in the opposite direction to the applied load. Hence, the body will remain in equilibrium, and no further elongation occurs. But note, this equilibrium will persist only till the elastic limit of the material. Shear stress is defined as the shear resisting force offered by the material per unit cross-sectional area when it is subjected to shear load. Mathematically, shear stress is equal to the applied force divided by the cross-sectional area. Here, F is the applied shear force, and A is the cross-sectional area. The unit of shear stress in the SI system is Newton per square millimeter or Pascal or kilogram per pound per square meter. In practical engineering applications, Newton per millimeter square is commonly used. Shear stress occurs in many real-life and engineering applications, such as connecting bolts that are in shear when the shear force is applied, and other are like tearing the paper where the paper between the blades is subjected to extreme shear stress. Because the area, $1 of the paper edge is so small, the stress, F, becomes high enough to fail the material instantly. And aircraft structural members, like when two fuselage skins slide in opposite directions, the bolt body experiences shear stress across its cross-section. Tectonic plate boundaries are the largest real-life example of shear. When two plates, transform faults, slide past each other, shear stress builds up until the rock shears and causes an earthquake. Let us summarize the key takeaways from this video. Shear load is a tangential load acting on a body. It causes transversal displacement with change in angle from the initial position. Shear stress is equal to load divided by area. For the same load, a smaller cross-sectional area results in higher tensile stress. Thanks for watching this video. Keep supporting us. In the next video, we will come up with the most important topic.